All right, everyone, we are back. So one of the most important plots that we're going to be generating in our class, especially because we're working with large data sets and trying to process that data set, those data sets are error bar plots. So determining error, finding error, it's going to be critical for a lot of our analysis. So let's go ahead. We're going to create some error values. Again, we'll do those a little bit more robustly in a little bit. So 0 to, let's do 0.4. 0.4. Let's create, let's just do 5 of them. So I've got my error values, I've got my time, which can be equal to a table. I goes from 0 to 4. See, error there, comma there, not our error that we want to plot. And then our data is going to be equal to random real. And let's just go from 0 to 5 for, again, 5 of those data sets. Remember, why did I do from 0 to 4? Because I have 1, 2, 3, 4, 5 elements in my list, actually. And I can check that length of time and make sure that it's the same as dat and error. Excellent. So whenever you're dealing with error bar plots, what we want to use is a function called around. So let's go ahead and click on that. This is new to I think it was probably in version 12 of Mathematica when it first started. So around basically gives me my value and then my error. So plus or minus whatever that error, that uncertainty is. So what we're going to do is we're going to create a table, or actually, yeah, we're going to create a table of basically my data values, and then we're going to actually put a function here around, and then so we got our data, comma, our error, same double I, and then we're going to do I goes from 1 to length of my data. Oops, my dat. So you see, it takes each of those values, this plus or minus the first value of error, et cetera, et cetera, et cetera, et cetera, and so forth and so forth. Now I'm going to transpose this data set with my time as such. So now I have x, y, and then an error bar on the y. So I can now do list plot, and I'm going to do this, and then you can go ahead and see, see, you see these little error bar plots. So I'm going to make it a little bit nicer. So I could do, to change those markers, plot markers, I could change it here. I could do blue and change it to 5 as such. So I could change the size of those. If I do this, this will be 10. You know, I could change essentially the size of those markers. And if I want to change basically the other ones, I could just do plot style, directive, and do blue, and then thick. So you could change those as well. So this is your error bar plot. And so you can see it's very easy. If you want to add error in the x-axis too, you just do the same thing. So this around function, that is very, 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 very important in order to visualize those values. So box whisker plots. These are really important tools to look at kind of the statistical information in your data sets. So for example, we still have our R1, R2, R3, the random list that we generated previously. So what we can do is we can visualize those data sets as box whisker charts. So we can look at, for example, R1, R2, R3, R4, and we could look at that, and then we could start to take a peek. So we see here, right? This one has a super small, again, all of these had basically an average around 0, but this is showing us the deviation in those data sets. So remember, we saw these deviations, these large error bars, because we had that huge standard deviations. We could also look at outliers in the data set as well. So black points would be outliers here in these data sets. Here in particular, we don't see any differences, but you can kind of look at those. And if we want to make these unique, we could do partition this and one, and then these will give them different colors. Actually, you could do chart style, and then we could do actually also chart labels as well. Chart labels, automatic. Well, let's do chart labels. It's not automatic. So let's do 1, or you could say R1, R2. So see, by putting them in parentheses, it's not reading it as a variable to evaluate. Actually, what are we doing here? Let's see Yeah, the chart labels. Oh, yeah, they're going to the bottom here. And I need to actually, if I want to do it, I could partition as one. And then I could do chart legends automatic. You could do those. Oops. Get rid of that. Oops. Let's do partition this one. But anyways, we could get rid of those later. But you can start to partition that data set. Actually, let me just get rid of this. Get rid of the partitions for a second. So let's do that. Let's get rid of these partition here. And then we can get into box Whisker charts. So again, these are showing, you can click on it and see max, mean, median, and then again, these are showing essentially those deviations in the data set. So you can see these are all non-distinct. I mean, this one maybe, the error bars are all overlapping here. So all these data sets are not statistically significant. So next time we're going to get into contour plots, density plots, vector fields, and then we'll play around with some manipulate and then insets. So see you all in the next video. Thanks. Bye.